two-phase interleaved CCM PFC controller by Texas Instruments. Welcome to the training module on Texas Instruments two-phase interleaved CCM PFC controller. This training module introduces the UCC 28070 two-phase interleaved CCM PFC controller and its basic operations. Power factor correction shapes the input current of offline power supplies to maximize the real power available from the mains. Simply put, it is the ratio of real power to apparent power. In the past, passive PFC solutions were used in high power applications to fully utilize the line power. These solutions required bulky 60 Hz iron core inductors. Nowadays, an active PFC is used in place of the passive PFC solution. This topology uses boost regulators and average current mode control techniques for current shaping. In high power applications, the input filter and the PFC boost regulators are much smaller than the older passive solutions. In PFC pre-regulators, the most popular topology used is the boost converter. This is because boost converters can have continuous input current that can be manipulated with average current mode control techniques to force the input current to track changes in line voltage. This figure shows the functional diagram of a two-phase interleaved boost converter. The interleaved boost converter is simply two boost converters in parallel, operating at 180 degrees out of phase. The input current is the sum of the two inductor currents IL1 and IL2. Because the inductor's ripple currents are out of phase, they tend to cancel each other and reduce the input ripple current caused by the boost inductors. Interleaving presents the power supply designer with some design options. Input and output ripple current cancellation can reduce the output capacitor's RMS current, reduce the EMI filter size, and also boost inductor size depending on the design requirements. The UCC 28070 is a single-chip interleaved power factor correction control circuit. This IC simplifies power design, increases system reliability, achieves greater power factor and high efficiency ratings in applications ranging from multi-kilowatt communication, server and industrial systems to digital TVs and PCs. The UCC 28070 integrates two pulse width modulators operating at 180 degrees out of phase. An improved multiplier design provides a shared current reference to two independent current amplifiers to ensure matched average current mode control in both PWM outputs whilst maintaining a stable, low distortion sinusoidal input line current. The UCC 28070 also contains a current synthesizer and quantized voltage feed forward to promote performance enhancements in power factor, efficiency, and transient response. Ripple current reduction due to interleaving is often referred to as ripple cancellation, but strictly speaking, the peak-to-peak ripple is completely cancelled only at 50% duty cycle in a two-phase system. At duty cycles other than 50%, ripple reduction occurs in the form of partial cancellation due to the superposition of the individual phase currents. Nevertheless, compared to the ripple currents of an equivalent single-phase PFC pre-regulator, those of a two-phase interleaved design are extraordinarily smaller. Frequency dithering refers to modulating the switch-in frequency to achieve a reduction in conducted EMI noise beyond the capability of the line filter alone. The UCC 28070 implements a triangular modulation method which results in equal time spent at every point along the switch-in frequency range. This total range from minimum to maximum frequency is defined as the dither magnitude and is centered around the nominal switch-in frequency F sub PWM set with R sub RT. The rate at which F sub PWM traverses from one extreme to the other and back again is defined as the dither rate. One of the most prominent features in the UCC28070 design is the current synthesizer circuitry that synchronously monitors the instantaneous inductor current through a combination of on-time sampling and off-time downslope emulation. During the on-time of the GDA and GDB outputs, the inductor current is recorded at the CSA and CSB pins, respectively via the current transformer network in each output phase. Meanwhile, the continuous monitoring of the input and output voltage via the VNAC and VSense pins permits the UCC28070 to internally recreate the inductor current's downslope during each output's respective off-time. The UCC28070 has been designed with a programmable cycle-by-cycle peak current limit dedicated to disabling either GDA or GDB output whenever the corresponding current sense input, that is, CSA or CSB, rises above the voltage established on the PK-LMNT pin. Once an output has been disabled via the detection of peak current limit, the output remains disabled until the next clock cycle initiates a new PWM period. A resistor divided network from V reference to ground can easily program the peak current limit voltage on PK-LMNT provided the total current out of V reference is less than 2 milliamps to avoid dropping off the 6-volt V reference voltage. The multiplier of the UCC28070 generates a reference current which represents the desired wave shape and proportional amplitude of the AC input current. This current is converted to a reference voltage signal by the R sub IMO resistor, which is scaled in value to match the voltage of the current sense signals. The instantaneous multiplier current is dependent upon the rectified scaled input voltage VNAC and the voltage error amplifier output V sub VAO. A major innovation in this UCC28070 multiplier architecture is the internal quantized VRMS feed-forward circuitry, which eliminates the requirement for external filtering on the VNAC signal and the subsequent slow response to transient line variations. The performance of the multiplier has high linearity and accuracy over most of the input ranges. External clock synchronization is able to facilitate using more than 2 phases for interleaving. Multiple UCC28070s can easily be paralleled to add an even number of additional phases for higher power applications. With appropriate phase shifting of the synchronization signals, even more input and output ripple current cancellation can be obtained. For 4, 6, or any 2 times n phases where n equals the number of UCC28070 controllers, each controller should receive a sync signal which is 360 divided by n degrees out of phase with each other. For a 4-phase application interleaving with 2 controllers, sync 1 should be 180 degrees out of phase with sync 2 for optimal ripple cancellation. The figure shows the paralleling of 2 controllers for a 4-phase 90-degree interleaved PFC system. The UCC28070 incorporates 2 identical and independent transconductance type current error amplifiers, that is, one for each phase, with which to control the shaping of the PFC input current waveform. The current error amplifier forms the heart of the embedded current control loop of the boost PFC pre-regulator and is compensated for loop stability. The output of the current error amplifier for phase A is CAOA and that for phase B is CAOB. Since the design considerations are the same for both, they are collectively referred to as CAOX, where the X may be A or B shown in the figure. The outer voltage control loop of the dual-phase PFC controller functions the same way as with a single-phase controller. The bandwidth of the voltage loop must be considerably lower than twice the line ripple frequency on the output capacitor to avoid distortion causing correction to the output voltage. The output of the voltage error amplifier is an input to the multiplier to adjust the input current amplitude relative to the required output power. Variations on VAO within the bandwidth of the current loops will influence the wave shape of the input current. At any response of the voltage loop to this ripple will have a greater distortion effect on high line current than on low line current. Therefore, the allowable percentage of third harmonic distortion on the input current contributed by VAO should be determined using high line conditions. The UCC28070 contains a variety of protection features, including output overvoltage detection, zero power detection, and thermal shutdown. It implements overvoltage protection through the continuous monitoring of the Vsense voltage. When Vsense rises above 106% of the regulation, or 3.18 volt, the GDX outputs are immediately disabled to prevent the output voltage from reaching excessive levels. Meanwhile, the CAOX outputs are pulled low in order to ensure a controlled recovery starting from 0% duty cycle after an overvoltage protection fault is released. In order to prevent undesired performance under no load and near no load conditions, the UCC28070 zero power detection comparator is designed to disable both GDA and GDB outputs in the event that VAO voltage falls below 0.75 volt. The UCC28070 has internal temperature sensing comparator that shuts down nearly all the internal circuitry and disables the GDA and GDB outputs if the die temperature rises above 160 degrees Celsius. The UCC28070 Interleaved PFC pre-regulator has many benefits. It can reduce EMI and boost inductor magnetic volume. The amount of reduction varies and depends on the design requirements and design trade-offs. The designer may choose to reduce either the boost inductor magnetic volume or cut back the switching frequency to reduce the size of the EMI filter. In some cases, just adding an additional phase will reduce the size of the EMI filter. Interleaving also reduces the RMS current in the boost capacitor, thus greatly reducing electrical overstress on the capacitor. However, the complexity and cost of the design will increase with each additional phase.